Hello, good afternoon. We are slowly inching towards the last few subtopics of differentiation. My name is Sosale Mohana. I'm a maths teacher and I've taught A-level maths for over 50 years across three continents, India, Kenya, and the UK. And I've taught the British curriculum for over 40 years. What I'm doing is basically trying to use my knowledge and experience to share, my knowledge and experience to help you revise what you have learned in school and prepare for an exam. So, you don't have to see the whole series like sitting in a classroom. You'll get fed up of my face, by the way, yeah. But if you want a particular topic, let's say, I don't know, then perhaps you could see that topic and see some examples and you'll recollect what your teachers have told you and you'll be better for that. Okay. So we finished parametric equations yesterday and today we will do what is called rates of change. Or sometimes when I was in school, we used to call it related rates. Instead of calling rates of change, we used to go, for example, I don't know. Suppose all of you will have done it sometime in your life. When you see a pond, it's human nature. I don't know why. We always take a stone and throw it into the pond. Next time when you throw it, look at what happens. You get those circular waves and the waves go on increasing. What are the things that are increasing in that circular wave? The radius is increasing, the circumference is increasing, and the area is increasing. So if you know the rate of change of a particular variable, there are three variables, the area, the circumference, and the radius, you can find the rate of change of the other two. So this is something related rates, or when two things are connected, and you know at what rate something is changing, you're asked to find at what rate the other thing is changing at a given instant. Why are we using the word at a given instant? We're using the word at a given instant because, do like this. I don't know whether you have tried this at home. Have you ever filled a bottle with water? Especially not a bottle with a bottle like this. Try it next time. See, up to here, this will raise steadily. You see, the amount of water coming in is a constant rate. You open the tap and it keeps on coming at the same rate. Here, it raises steadily. But as it comes here, you see that it fills up faster because the shape is different. So the height increases at a faster rate. Yeah. So in other words, at a particular height, what would be the rate at which it is increasing? Of course, we need a mathematical equation for that curve and so on. So it's questions like this we're going to deal with. The rule is very simple. As I did in maximum and minimum, read the question, write down the variables, and write down any rates of change and values given. Rate of change means here we're going to differentiate with respect to t, time. Rate of change, of course, even though dy by dx itself is rate of change of y with respect to x for small, infinitesimally small changes in x. Here we're going to consider rate of change with respect to time. So identify the variables, then write down any values given, any rates given, and what rate has to be found. And then find a relation between your variables, do normal differentiation, apply chain rule. That looks very simple, so let me take an example to show you what I mean. For example, I have a rectangle whose width whose length is 6 meters more than the width. And you've been given x is increasing at 0.01 meter per minute. What is the rate of change of area? What's the rate of change of perimeter? I'm taking a simple example. Later on we'll go to complicated ones. A rectangular being, I did it, I shouldn't have given this, it doesn't matter. So the variable has been identified for you. So area is x times x plus 6 or x squared plus 6x. Perimeter is x 4x plus 12. You have to find what is dA by dt, what is dP by dt when the shorter side is 0.5 meters at a particular instant. You know dx by dt is 0.05, no 0.01 and x is 0.5. So identify the variables, list what values have been given and what values you have to find. Write down equations connecting the variables. Let's find area. Now to find area, rate of change, I need dA by dt. But A is in terms of x. So using chain rule, I can say it is dA by dx times dx by dt. Oh yeah. In some cases, later on, in this case, you know dx by dt, you are finding dA by dt. In another question, maybe you are given the rate of change of volume, you have to find the rate of change of surface area. So from volume, you get the rate of change of radius. From radius, you get the rate of change of surface area. But to do all that, many a time students get themselves into knots trying to use different methods. Stick to just one formula, it will work. Whatever you know, you substitute. dA by dx, I know 2x plus 6 times dx by dt. Now I know all the values. What is x? 0.5. So 2 times 0.5 plus 6 times 0.01. 2 times 0.5 is 1, 1 plus 6 is 7. So it is 0.07 meters squared per minute. That's the rate at which the area is changing. Yeah? Okay. What about the perimeter? Perimeter is 4x plus 12. So dP by dt is dP by dx times dx by dt. dP by dt is 4 dx by dt. Look, if I have an x, I substitute for x. If I don't have an x, I don't substitute for x. So therefore, it is 4 times 0.01, which is 0.04 meters per minute. That was quite a simple question, yeah? But then, all questions are not that simple. So I will take up a more complicated question, and I think I'll have to write the question. So what I'll do will be, I will write the two questions and start the lesson again. Of course, as I always tell you, it doesn't affect you. The IT experts here in the recording studio, they know how to edit whatever I don't want. So you will not be bored. So I will write the question and then call you back. A big hollow right circular cone shaped storage facility is 27 meters high and its base radius at the top is 18 meters. And storage liquid, some factory, so the liquid is being poured in at 3 meter cube per hour. Everything is per hour. Find the rate of rise of, as the liquid pours in, the level of water rises. So the liquid rises. Find the rate of rise of level of the liquid when the depth is 9 meters. So you've been given that depth is 9 meters and you're asked to find the level. That's the question. I didn't want to write the whole question, so I drew the diagram. So what the first thing I said you do? Identify the variables. I'm talking of the level of liquid. As the liquid increases, the volume increases, the radius of the base increases, and the depth or the height increases. So therefore, volume is V, radius of base, radius of liquid surface is R, and then depth of liquid is H. Okay? You are being given liquid is being poured into the container at 3 meter cube per hour. So dV by dt equal to 3 meter cube per hour. You are asked to find what is dH by dt when H is 9 meters. That's the question. So identify the variables, write down any information given, write down what rate you are asked to find. Good? Then, what's the relation between V, R and H? V equal to 1/3 pi R square H. I need to find dV by dt. I cannot find dV by dt as such. Can somebody tell me why? Yes? We don't know R, we don't even know R and H. No. The reason is because there are two variables. Either I can find dV by dH or I can find dV by dr. I can't do dV by d or dH. No partial derivatives. Okay? So, in fact, you come across later on if you do maths at university, del V by del R del H and del V by del H del R. So, first you differentiate with respect to H considering R as constant, then you differentiate with respect to R considering H as constant, partial derivatives. Fortunately, that's too far beyond even further maths, so let's not go into that. Okay? So, therefore, unless I have only one variable, I cannot. Now, how am I to link the V, the R, the H? How am I to link R and H to get only one variable? Either H or R. Any hints? Let me give you a hint. You go back to basic GCSE. Still didn't click? I know there's already somebody. Yes, yes. Symmetry triangles. Perfect. Or trigonometry. Now, let me look at this cross section. Do you agree that cross section where you can see a triangle there? This is R, that is H, that is 27, that is 18. If you forget basic similar triangles, use trigonometry. Suppose I call this angle as theta. Tan theta is R over H is also equal to 18 over 27. Now comes the question, do I substitute for H or do I substitute for R? That comes from here. I know H. So I need H. I don't need R. So R equal to 2 over 3 H. So this will come later. So volume equal to 1/3 pi times 2 over 3 H, the whole squared H, or 4 pi over 9 H cube is the volume. Now I have everything in terms of one variable. I can differentiate. So dV by dt equal to dV by dH times dH by dt. dV by dH, when you differentiate this, I get 3h squared. So it is 4 pi by 3 h squared dH by dt. Now, please don't, this is what I was talking about. You know dV by dt, students try to find what is h is equal to v power 1/3. Please don't do it. Stick to dV by dt. You know this, find that. That's easier than trying to figure out what could dH by dt be. So from here, dV by dt is 3 equal to 4 pi over 3 h squared is 81 dH by dt. Is my differentiation correct? You see, that was 27. Idiot. I knew I had gone wrong somewhere because 3 squared is 9, 9 and 3 is 27. So when I differentiate that, this will become 9. You know why? 3 and 27 gives you 9. So it's 4 pi over 9. So what is dH by dt? Can I do it here? So dH by dt equal to 3 times 9 over 4 pi times 81. 9 nines are 81, 3 threes are 9. So 1 over 12 pi meters per minute. Can someone visualize what's happening here? Remember, as it increases, the rate at which the height is increasing slows down. Yeah? Have you noticed that? Okay. If not, take a cone, try it at home. So, I have taken about 15 minutes. So, I'll stop at this stage and do one more lesson. What I'll do for the next lesson will be, I will write down the questions, then call you. Then start the lesson so that I can just zoom through. Yeah? Okay, I'll see you in the next lesson. A few more questions on related rates. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.